Hello all, welcome back. In this video, we will see a concept called data drift and how we detect this data drift using a tool. It's an open source tool, evidently.ai. Apparently, this is used by globally by many data scientists and ML engineers. So, first of all, you might be hearing that your ML model is losing accuracy because of this term called data drift. So what is it? So basically data drift is nothing but the statistical properties of this model's input data is changing. So for example, like now if your model is predicting a fashion trends, and the fashion trends vary from season to season, and your model should be able to accommodate that. And if your model is not performing well, that means the model that is trained on summer fashion is performing you're using that model to predict the winter fashion trends. So basically this is it. So the live data that your models is becoming like different from the data that it was basically trained on. This is the quick summary. Why it happens is like in real world, like I said, user behavior shifts, market trends change, and new external events also occur, like economic shifts, so many things. uh, and also like something called system changes, like there are like different data collection methods, sensors, and the updates that will go onto these sensors and some other upstream systems. Because of this, the models will tend to degrade over time, and that the model predictions will become less useful and less accurate, and also the insights that you'll get from this model will be stale. uh, Basically, like there are two types of drifts. One is feature drift. So feature drift is nothing but when the input variable distribution changes, like average customer age kind of shifts from like over time to time. Something called concept drift. Second term is concept drift, where the relationship between input and output changes. So the reason for like the reason that was like for the customer churn might be in 1 month it is one reason, and in next month it is another reason. So what is the ideal solution here? So we have to monitor this data drift and concept drift trends continuously. You have to make sure that you once your ML model is deployment, you should be tracking this production data. Along with that, like based on if you're seeing any drift in data or concept, you should trigger the model to be retrained. So you need to retrain your model timely. So you will update your model with fresh representative data, uh, so that like when any drift is detected, your model will take care of that drift, and it will give you reliable and accurate results over time. Now let me show you how Evidently is used in a simple Python script. So this is a simple script that I created. It's basically dummy data where you will I'll vary the data and show you how we can able to see the logs, see the plots, and the different uh, distribution changes in the Evidently. So what you just need to do is you need to pip install Evidently library, and you just need to import these functions: report, dataset, and data drift preset. I'll show you what it does in a minute. Before that, I'm just doing is I'm creating a simple data frame, that is reference data set. It has like four features: one, two numerical, one categorical, and one target. And this has a mean of 50, and with this various numerical properties, and it is comes with 1,000 data points, and similarly like this. And there are three categorical features. Now what I'll do is I will show you the current data. So I just modified this current data just to be different. So the mean earlier was 50, now I modified it to 55, and the standard deviation was 20, now I increased to 30. Basically the variance is increased here. Now what I do is I'll just create a report with data drift preset, and I am going to create this run this report using the current data and also the reference data. So now this is my data drift report that actually detects each and it compares the numerical feature one with in reference data to current data, and so on like that. Now once this report is prepared, we typically save this into HTML file, so that like we can able to see nice uh, graphs here. So I'll show you once you hit the Python code, once you run a data.drift.report will be created, and if you open the report, this is how you'll see. So like I said, there are two numerical features and one target variable and one categorical features. So you can see this plots, detailed plots, like how is my reference distribution and the current distribution. And it runs typically some statistical tests. So here, because of this categorical variables, it runs a z-test, and it shows a p-value. Here p-value is like greater than 0.05, which is the significance level, and therefore like the null hypothesis not rejected, and it is showing us data drift not detected. But for the numerical features, what it does is it runs a test called ks test. So ks is like Kolmogorov-Smirnov test. What it does is it compares the cdf distributions of these two data sets, and it measures the maximum distance between these two cdf values. So, and also it outputs the p-value. So p-value is like, if it is lower than the significance level, then here it is like exactly zero. If it is p-value is less than 0.05, the significance level, my data drift is detected, and it is flagging that the drift is detected. And same for like numerical features, because I modified in numerical feature 1 I modified the mean, and numerical feature 2 I modified the variance. And for categorical features also, if there is variation, it runs a chi-square test, and here also it outputs the p-value, and it checks against the significance level, and report that if the data drift is detected. And on the top of this, like you can see that it will clearly summarize the data drift is detected. That's it. This is the end of the tutorial. So evidently it's a very popular open source Python library used by ML engineers, ML ops engineers, and data scientists widely. This will help most of the engineers like evaluate, test, and monitor data and AI powered systems, especially ML models and LLMs. So yeah, that's the end of the video. Thank you. Have a nice day.